All right, Math 1, Unit 7, Section 10, Graphing Systems of Inequalities. So we're doing the same thing as what we did yesterday, except this time there's sometimes going to be a different variable, and sometimes it's not going to be in slope-intercept form. Actually, a lot of the time it's not going to be in slope-intercept form. So I'm thinking my iPad's just being silly, and that's supposed to be a y, which would make that y and that y. Is that what happened on all these? Looks like it. All right, so if you have a different letter that's like that, that's not an X and a Y, you can just substitute in an X or a Y if it's missing. So what I'm going to do is I'm going to take my orange one, just like how I did last time. I'm going to color code, and I'm going to solve for Y. That way I can graph it using slope-intercept form. So I'm going to say, well, if I move the X to the side, I'm going to have, well, 2Y is greater than or equal to negative X minus 4. And then if I divide by 2, I'll have y is greater than or equal to negative 1/2 x minus 2. Now I can graph this. My negative 2 is my intercept, and my slope is negative 1/2. So I'm going to go down 1 and over 2. Down 1 and over 2, or I could go up 1 and left 2. And it's a solid line because there's a little equal to sign underneath there. There's that line there. All right, now for the green equation. Again, I'm going to solve for y. So if I move my 2x to their side, I'll end up having a y by itself. So y is greater than negative 2x plus 1. This one's a little bit easier because I didn't have to do any more work with it. This is already it. So my intercept is at 1. Oop, and then I should have a little line under there. There it is. And my slope is a negative 2, so I'm going to go down 2 and right 1. Down 2 and right 1, or I can go up 2 and left 1. Again, this is a solid line because it is greater than or equal to. I didn't plug in a point yet, so I'm going to plug in 0 into both of them. I'll plug it into the orange one first. I probably wouldn't do that. I'll do that down here. The orange one, I'm going to plug in 0. I'll say, well, 0 is greater than or equal to negative 1/2 times 0 minus 2. So that says that 0 is greater than or equal to negative 2. And that's a true statement, right? 0 is bigger than negative 2. So I'm going to shade up. Now for the orange one, or not orange, green. Where do I want to do? I'll just do it right below it. I'll say, well, 0 is greater than or equal to negative 2 times 0 plus 1. So 0 is greater than or equal to 1. And that is not a true statement, right? So we're going to have to shade away from the 0. And then the question is, well, where do they overlap? And right over here, we can see that they overlap right there, and we shade in the rest of it. Right? Just like yesterday, if you are confused, you're always able to just go ahead and shade the whole thing. If I shaded my orange, I'd be like this. And if I shade my green, it'll be like this. And then we can see that they overlap there. I normally don't like to shade like that because whenever I'm using a pencil, the graphite it's not different colors and I just end up confusing myself. So this is the way that I like to do it, using the arrows. All right, number 2. Again, I'm going to have to put in these little y's there. So if I were to solve both of these for y, the top one, I'll make it orange. Let me change this back to normal. Orange, that's going to be y is less than or equal to negative 5x plus 2. What I did there is I took this 5x and I put it on the other side. I subtracted 5x from both sides. Now for the green one, I need to get my y by itself. I'll subtract x from both sides. So I'll have y is greater than negative x minus 2. So there we are. There are our 2 lines ready to graph. I'll go back to the orange one. The orange one has an intercept of 2, and it has a slope of negative 5. So I'm going to go down 5 and right 1. And I'm not going to be able to do another point on there, so that's it. It's a solid line because it is less than or equal to, and there's my line. I'm going to go ahead and plug in 0, 0, so I'm plugging in the origin there. So I'm going to say, well, 0 is less than or equal to negative 5 times 0 plus 2. So 0 is less than 2. Well, that's a true statement. 0 is smaller than 2. So I'm going to shade that direction. The green one, I'm going to plug in this. Well, actually, I need to start off by graphing the green one. I'll have negative 2 is my intercept. And then my slope is negative x, so negative 1. So, well, my slope is just plain old negative 1, not the x. So I'm going to go down 1 and right 1. It's going to be a dotted line. And it's a dotted line because this is just greater than. It's not greater than or equal to. Now to plug in for the green one, I'm going to plug in 0. So I'm going to say, well, 0 is greater than negative 0 minus 2. So 0 is greater than negative 2. And then the question is, well, is that a true statement? And yes, it is. 0 is bigger than negative 2. So I'm going to shade towards 0. We can see pretty easily here. I think this is one of those that is nice to see. That here's the spot that we end up shading. All right. Number 3. The top one here, well, that's not a normal line. That is a horizontal or a vertical line? That's going to be a vertical line. X equals is a vertical line. So I put a dot on negative 2, and then I draw my line through it. It's a solid line because there's an equal to sign under there. Now to plug in 0. If I say, well, 0 is less than or equal to negative 2. Well, is 0 smaller than negative 2? No. So I'm going to shade away. Like that. For the second one, I'm going to solve for y. So let me pull this up here. Ooh, I'm going to want to use this in green. I'll subtract my x to the other side. So I'm going to say, well, negative 2y is greater than or equal to negative x plus 4. Now here's going to be a tricky piece of this. And I know we've done this in the last unit, but it might be easy to forget. We're going to divide here by negative 2. Whenever you divide by a negative number, you have to switch the inequality. So here's what I mean by that. So we're going to have y here. We're going to have 1/2 x, and we're going to have minus 2. But what goes in the middle here? It's going to be the arrow is going to point the other direction, or the alligator will point in the other direction, however you want to think about that. See how the top arrow, this one up here, if you think about it as an arrow, it points right, and then at the bottom it points left. We had to switch it because we divided by a negative number. That's something you always have to do with an inequality. Anytime you divide by a negative, you switch the sign. So now we've got this written out in slope-intercept form. My intercept is at negative 2. My slope is 1/2, so up 1 over 2, or down 1 left 2. I can draw my line through it. It's a solid line. And now I need to plug in 0. So I'm going to plug in, well, 0 is less than or equal to 1/2 times 0 minus 2. So 0 is less than or equal to 0 minus 2. 0 is less than negative 2. Is 0 smaller than negative 2? No. So I'm going to shade away from the point 0, 0. And this is one of those that just has a little sliver. It's going to be this little sliver that you shade. All right, number 4. I'll draw in my y's. This top one here, I'm going to subtract 2x to the other side. So I'm going to have y is less than negative 2x plus 3. Now that's ready to graph. I have an intercept at 3. and the slope of -2. So I'm going to go down 2 and right 1, down 2 and right 1, or I can go up 2 and left 1. It's going to be a dashed line or a dotted line. And now I need to plug in my 0. So I'm going to say, well, 0 is less than -2 times 0 plus 3. So 0 is less than 3. Well, that's a true statement. 0 is smaller than 3, so I'm going to shade towards the origin. All right, now for the green one, I'll subtract 2x to their side. So I'm going to have 3y is greater than -2x minus 3. Now here I'm going to divide by 3. Because I'm dividing by a positive number, I do not have to switch the sign, right? In number 3, I had to switch the sign because I divided by -2. This one I'm dividing by a positive 3, and I do not have to switch the sign. So y is greater than -2/3 x minus 1. My intercept is at -1. My slope is -2/3, so down 2 and right 3. So down 2, right 3, or up 2 and left 3. It's going to be a dashed line also. And now I need to plug in the point 0, 0. So I say, well, 0 is bigger than -2/3 times 0 minus 1. So 0 is bigger than -1. And that's a true statement. 0 is bigger than -1. So I'm going to shade towards the origin. This one we can see right over here that we're going to be shading this sliver in there. Just like that. All right, number 5. Ooh, this one's nice. It's already in slope-intercept form for us. The top one I'll make orange. My intercept is at 1. My slope is 3, so up 3 and over 1, or down 3 and left 1. It's going to be a solid line. And it's a solid line because this is less than or equal to. There's that line underneath it. I'm going to plug in the point 0, 0 to it. So I'll say, well, 0 is less than or equal to 3 times 0 plus 1. So 0 is less than or equal to 1. And that's a true statement. So I'm going to shade towards 0. This one here, the green one, the intercept is at -3, and the slope is also 3. So I'm going to go up 3 and over 1, up 3 and over 1, and it's also going to have a solid line. Now I'm going to plug in 0, 0. So I'm going to say, well, 0 is greater than or equal to 3 times 0 minus 3. So 0 is bigger than -3. And the question is, well, is that a true statement? And yes, 0 is bigger than -3. So I'm going to shade towards the origin. And this one's kind of a neat problem because we see that we're going to be shading this sliver in here between the lines. All right, number 6. Back to normal where we have to rearrange them. The top one, I'm going to start off by subtracting 3x from both sides. So I'll have -2y is greater than -3x plus 4. Now I'm going to divide by -2. And whenever I divide by a negative, I have to flip the inequality. So this is going to point the other direction. I'll have y, and then over here I'm going to have -3 over -2 will give me a +3/2. And then +4 over -2 gives me a -2. My intercept is at -2. My slope is 3 over 2, so I'm going to go up 3 and over 2. And I'll do that again, up 3 and over 2. I'll go the other direction too, down 3 and left 2. This is going to be a dotted line, or a dashed line. And now I need to plug in the point 0, 0. So I'm going to say, well, 0 is less than 3 halves times 0 minus 2. So 0 is less than negative 2. And the question is, well, is that a true statement? No, 0 is not smaller than negative 2. So I'm going to shade away from 0, 0. Now for the green one. This is the same thing as y is greater than negative x plus 3. All I did there was I subtracted the x to the other side. So I have an intercept at 3 and a slope of negative 1. This is also going to be a dotted line because it is not equal to, it's just plain old greater than. Whenever I plug in the point 0, 0, I'm going to have, where do I want to do it? I'll do it over here. 0 is greater than negative 0 plus 3. So 0 is greater than 3. Well, that's not a true statement. 0 is not bigger than 3. So I'm going to shade away from 0. And then I can see that I shade this little triangle piece over here. All right, there's number 6. Moving on to number 7. We'll take the orange one first, the top one. I'm going to subtract 2x to the other side. So I'll have, well, 3y is less than or equal to negative 2x minus 9. I'm going to divide by 3, so I'll have, well, y is less than or equal to negative 2/3 x minus 3, right? 9 divided by 3 is 3. So I can graph this now. I have an intercept at negative 3. My slope is negative 2/3, so I'm going to go down 2 and right 3. And I'm also going to go up 2 and left 3. This one gives me a solid line because there's the equal to in the inequality. I'm going to plug in the point 0, 0, so I'm going to say, well, 0 is less than or equal to negative 2/3 times 0 minus 3. So 0 is smaller than negative 3. 0 is not smaller than negative 3, so I'm going to shade away. All right, now for the green one. I'm going to start off by subtracting 2x to the other side, so I'll have negative 3y is greater than or equal to negative 2x minus 3. Now I'm going to divide by negative 3 because that's what is in front of my y. So that flips my inequality, so it needs to point the other direction. I'm just going to have a plain old y, and then negative 2 over negative 3 gives me 2/3 x, and then negative 3 divided by negative 3 is 1. So I have an intercept at 1 and a slope of 2/3. So up 2 and over 3, or down 2 and left 3. This gives me a solid line. And now I'm going to plug in the point 0, 0. So I'm going to say, well, 0 is less than or equal to 2/3 times 0 plus 1. So 0 is less than 1. And that's a true statement. So I'm going to shade towards 0 here. And I can see that the spot that I shade is this piece over here. All right, number 8, last one. Okay, number 8. I'm going to start off with this orange one. I'm going to pull it over here. And I'm going to subtract 2x to the other side. So I'm going to have negative y is less than negative 2x minus 3. Now I'm going to divide by negative 1, or you can think about it as multiplying by negative 1. I'm going to switch the signs of everything. So y, and then I need to swap the direction of this. And I'm swapping the direction because I multiplied or divided by a negative number. 2x plus 3. My intercept is at 3. My slope is 2, so up 2 and over 1, or down 2 and left 1. And I'm going to have a dotted line. Now I'm going to plug in the point 0, 0, so I'm going to say, well, 0 is greater than 2 times 0 plus 3. So 0 is greater than 3. Is that a true statement? Is 0 bigger than 3? No, 0 is not bigger than 3, so I'm going to shade away from the origin. Now for the green one, I'm going to start off by subtracting 2x to the other side. So I'm going to have negative 3y is greater than or equal to negative 2x plus 3. I'll divide by negative 3, and whenever I do, I'm going to need to swap this sign. So the arrow points in the other direction. Y, and then negative 2 over negative 3 is going to be 2/3 x, and then 3 over negative 3 will be negative 1. My intercept is at negative 1. My slope is 2/3, so up 2 and over 3, down 2 and left 3. This one's going to give me a solid line. Now I need to plug in the point 0, 0. So I'm going to say, well, 0 is less than or equal to 2/3 times 0 minus 1. So 0 is less than or equal to negative 1. Well, is that a true statement? Is 0 smaller than negative 1? No. So I'm going to have to shade away from the origin. This one is just going to have this little bitty sliver over here highlighted. All right, there we are.